Hello everyone, and welcome to an introduction video about Pre-Calculus Lesson 3.2, Polynomial Functions and Their Graphs. So we're going to start with a review of some terms. The first term I have for you is standard form. So standard form, when referring to a polynomial, takes all of the terms and puts them in order from greatest degree to least degree. So in my case here, I would need to move this 6x cubed to the beginning because it has a greater degree than this x squared. Now, just remember, it always keeps the sign that's directly in front of it. So this plus sign is going along with the 6x cubed when I move it. So I have 6x cubed. The next degree is the x squared term. And again, it's going to keep the sign that's in front of it. This was positive, so it's plus. Okay, and then I have the minus 5x, that's the next degree I would use, and then plus 10 would be last. So that's standard form of this polynomial, from greatest degree to least degree on those terms. Next we have leading coefficient. The leading coefficient is the number, the constant, that's multiplied by this leading term. So in my case, the leading coefficient is this 6 right here because it's on the leading term. Now, hypothetically speaking, if this had been in standard form, the leading coefficient would be that invisible 1 that's next to this x squared. That is still a coefficient, so that invisible 1 would work. Next, the leading term, that is the first term, this 6x cubed is the leading term of my polynomial because it is the first term that shows up when it is in standard form. Now, a monomial is just a single term in this. So this x squared is a monomial, 6x cubed is a monomial, negative 5x is a monomial, and 10 is a monomial. So it's a single term, and it can be the definition for a function. So for example, a monomial function could be f of x equals x squared, and that is a monomial function. As soon as you put a plus or a minus sign here, it turns it from a monomial into a polynomial. Now the last term we have is continuous. A continuous function is one that essentially can be drawn without picking up your pencil or, in my case, marker. So it's a continuous function, one that can be drawn without picking up your marker or your pencil. In Chapter 2, we discussed piecewise functions. These functions do not have to be continuous, like this one here. Notice it jumps from this open circle up to this filled-in circle. So the piecewise functions don't have to be continuous, but sometimes they are. Now, continuous functions can have points in them, like this. This is a absolute value function. It technically is continuous. I can draw it without picking up my marker. So continuous just means essentially that it is one continuous function that is connected without any jumps in it or without any holes in it. And holes are something we're going to discuss in lesson 3.7. A hole is where there's just one x value where the function is not defined. So you can call this not continuous because it has a hole right here. So I can't draw it without picking up my pencil because I should really pick up my pencil right here and then keep going. So continuous. Next, we're going to talk about how to graph a polynomial function. So I've basically set up 5 steps that I like to use for graphing a polynomial. The first step is to find the zeros and the y-intercept. Then we plot those on our graph. We make a table of values to get more points. And then we determine the end behavior and then connect everything to create our graph. So let me show you an example of how that would work. So here is my polynomial. P of x equals x plus 2 times x minus 1 times x minus 3. So the first thing I need to do is find the zeros. And this is already factored, so that creates an easy situation for me. I can easily find the zeros. The 0 for this x would be negative 2. The 0 for this x would be positive 1, and the 0 for the last x would be positive 3. So I'm going to go ahead and put those on my x-axis, negative 2, positive 1, and positive 3. Next, I need the y-intercept. Now, if this had been all multiplied together, it would be the constant term that's on there. For example, on this function that we had looked at earlier, the y-intercept would have been 10, that constant term. But notice my new function is not multiplied out. So there's a fun thing that we can do to help us out with this. All we do is we take all of these constant numbers, we multiply them together, because that's what would form that constant term if we had done this multiplication. So all I have to do for my y-intercept is multiply together positive 2 times negative 1 times negative 3. And 2 times negative 1 times negative 3 is positive 6. So that's my y-intercept. That would go right here. Okay, next, I've done steps 1 and 2. So I found the zeros and the y-intercepts and I graphed them. Now I need to make a table of values to get more points. Now, for my class, at least, it's okay to just have 1 point between each pair of zeros. But the more points you have, the more accurate your graph is going to be. So what I'm going to do is I'm going to pick x values and I'm going to find y values. And I can do this using a calculator. Now, I can pick -1 between here. Technically, I have the y-intercept and that would work. So I don't need to do that, but it will make my graph more accurate. So I'll put in -1. And I'll also pick a number in between 1 and 3, which 2 seems like a very good option here. So we're going to do -1 and 2. Now let me show you how to do this on your graphing calculator. If you have the newest operating system, there is a lovely thing that you can do with this. If you go to your y equals menu and you type in your function, that is where we're going to start. So x plus 2, x minus 1, and x minus 3. Okay, so there's my function in my y equals menu. Now, if you wanted to, you can hit second and graph and go into the table and you can find values here. And it gives you very standard numbers here, and there are ways to change the numbers it gives you. But that gets into some menus that I don't want to go into in this video. Another way you can do this, and this happens to be my favorite way because you can put in any value you want. If you quit out of your menus from up here and go back to your home screen, if you hit alpha and trace, we're going to select 1, which is y1, and that's where we entered that function into our y equals menu. It was in y1 right here. See, it's y1 equals this. So we have y1, and then I just put parentheses and whatever number I wanted to evaluate for. So I wanted to evaluate for -1, and I close those parentheses and hit enter, and it gives me 8. So evaluating for -1 gives me 8. Okay, and then I'm going to do the same thing for 2. So I'm going to hit alpha trace, I hit enter on y1, and I can put in a 2 there. Now, you didn't have to hit alpha trace again. What you could have done is hit second and enter. It would grab that previous entry. Another thing you can do is use the up arrows and scroll up to the previous entry and then just edit this as you want to. So maybe I wanted to put in a 3. I grabbed it, I just typed over with a 3, and I get a value for it. Okay, so that's a lot of different ways you can evaluate using your calculator. Calculators are beautiful things. So now all I need to do is put these points on my graph. So I have -1, 8. So -1, this was 6, 7, 8 is right there. And I have 2, -4. So 2, -4 will be right here. So that was step 3. Next, we're on to step 4, end behavior. Now, if you're in my class, this is something that we're going to talk about in class, not in this video, but I'll give you a nice taste of it now. So basically, we need the leading coefficient of this polynomial. And just like we did with the constant term, we can get that simply by multiplying all of these first terms together, all of these x's together. So x times x times x is x cubed, and that's my leading coefficient. Now, if this is positive, that means on the right side of my function, it's going to be pointing upward toward the positive numbers. Okay, and then this is odd. It's an odd power on this. So that means that the left side is going to point in the opposite direction of this one. So it's going to point downward from here. Now, if you didn't catch those rules about what's going on there, don't worry, we're going to talk about that in class, but it can be really helpful to know where these arrows are supposed to point, because sometimes what's going to happen is it's going to touch the axis and bounce back. So maybe like these were your zeros, and it'll go up, it'll touch this one, and then it'll curve back down before it curves up to touch that one, and it'll make like this W shape. That does happen, so it's always good to know your end behavior. Okay, now the final step for this is to just graph. So just connect this with a curve. So I'm just going to draw a curve here, and it's not going to be perfect because I didn't get all the possible points. Now, I guessed that it might go up further than this. This might be the top of the curve. This was just a big guess about everything, but essentially I just need a curve that's going to connect all of these points. So let me give you one more example. In this one, it's going to be an example of one where we would have to factor first before we could graph. And we're going to go through all these steps again. So my new polynomial function is x cubed minus 2x squared minus 3x. So step one of factoring this is to factor out the GCF. So I get x times x squared minus 2x minus 3. And then I need to factor this quadratic. So essentially you're looking for two numbers that multiply to negative 3 and add to negative 2. And that's going to be negative 3 and positive 1. So my factored form would be x minus 3 and x plus 1. So this is my factored form now. The next thing I need to do is find the zeros and the y-intercept. So my 0 for this x is 0, for this x is 3, and for this x is going to be negative 1. And I'm going to go ahead and put those on my graph. Okay, and the y-intercept is going to be the constant term that would have been right here. And there's nothing there, which means the y-intercept is 0, which is kind of obvious from our graph because we already have a point on it. So that is steps 1 and 2. Now we're going to make a table of values. So I need x values and y values. So I need something in between these 2 points. I'll do negative 1/2 right there. And I can pick the 2 values that are going to be here. Since we're using a calculator, it's not too hard to get that extra number, so I'm going to go ahead and do it. And those are the values I'm going to use. So now let me show you again how to do the calculator steps. In your calculator, in your y equals menu, you're going to clear out anything that's there, and you're going to type in the function that we had. So I have x cubed minus 2x squared minus 3x. And then we're going to quit out of this. I'm going to hit alpha and trace. I'm going to do y1, and then I need parentheses. You have to do parentheses. And I have negative 1/2 here. So I did negative 1 divided by 2, and I got 0.875. Okay, now I'll do the same thing. So alpha trace y1 of 1. Oops, I missed the 1 there. And that's negative 4. And I'll do y1 of 2. And that's negative 6. Okay, so those are my points now. So negative 1/2, I got 0.875, so that's a little less than 1. For 1, I got negative 4, which is here, and for 2, I got negative 6, which is there. Now the final thing we need to do is end behavior. Notice we had an x cubed as our leading term. Its coefficient is positive, meaning that the right side of this is going to point upward toward the positive numbers. It has an odd degree, meaning that the left side is going to point in the opposite direction. Now the final step is just to connect this with a curve. So I come up, I go down, and I'll just curve back up this way. And that's my graph. So that's it for this video. Make sure you let me know in class if you have any questions.